Okay, how to assess the carbon footprint? Okay, so we mentioned that in the atmosphere, there is not only one kind of greenhouse gases. We have the carbon dioxide, we have the nitrous oxide, we have the methane. So all these will contribute to the global warming. So we need a measurement which we can use to combine the effect of these greenhouse gases. So carbon footprint is a measurement of the impact that the activities of an individual, the building, organization, event, or a city on the environment, and quantified in terms of the amount of greenhouse gases that they produce. So when we say what is your carbon footprint, it means that what is the amount of greenhouse gases you produced. Okay, so maybe by arranging an activities. So I am arranging a green campaign, but I may need to use some material. So maybe I need to print the T-shirt. Maybe I need to use. I need to do the publicity, and then I will arrange some competitions, and all these may produce carbon dioxide. So for your activity, what is the carbon footprint? How much greenhouse gases will produce by arrange your so-called green activities? Okay. And carbon footprint is also the total set of greenhouse gas emission caused directly and indirectly by an individual, organization, event, or a product. Okay, so in summary, the carbon footprint is the amount of greenhouse gas that you produced, okay, by a person, by a building, or by an organization, event, and so on. Okay, another definitions of carbon footprint, it is a measure of the total amount of carbon dioxide, methane, and other greenhouse gas emission of a defined population, system, or activity, considering all relevant sources, sink, and storage within the spatial temporal boundary of population, system, or activity of interest, calculated as carbon dioxide equivalent using the relevant 100-year global warming potential. So this definition is more specific. Okay, so for the emissions of the carbon dioxide, we also consider the sink, okay, and the storage. So maybe you produce carbon dioxide when you use electricity, okay, indirectly. When you turn on the light, you didn't directly produce carbon dioxide, but you consume electricity. And for the production of electricity, you need to burn the fossil fuel, and then it produces the carbon dioxide. Okay, so the production will include directly and also indirectly. Okay, maybe you go to have a BBQ and you burn the charcoal for cooking for the barbecue. So you are directly contributing to the carbon dioxide emission. And when you consume electricity, indirectly produce the carbon dioxide. And according to this definition, we also consider the sink of the greenhouse gases. So maybe you produce the carbon dioxide, and at the same time you plant. Okay, you plant some trees, so the trees can help to is a sink to the carbon dioxide. It converts carbon dioxide into oxygen. Okay, so we take all these kind of activities into account, and we find the net productions, the net generation of the carbon dioxide. And we have a term called carbon dioxide equivalent. Okay, not only carbon dioxide emission, but carbon dioxide equivalent. So we will learn what does it mean. And the year is usually 100. Okay, we consider the effect of the greenhouse gases when they last for 100-year time in the atmosphere. Okay, so we need to use a parameter called carbon dioxide equivalent. It is because different greenhouse gases have various radiative forcing and the atmospheric lifetime. And radiative forcing means the rate of trapping heat at the atmosphere. Okay, the rate of trapping heat. So remember, for the greenhouse gases, it will absorb and re-emit the heat to the atmosphere. So the radiative forcing will means the ability to trap the heat in the atmosphere. And different gases will have different lifetime, different length of persistent time in the atmosphere. So in order to compare fairly of different gases, we use the equivalent, the carbon dioxide equivalent to quantify their effect. Okay, so this is a this figure shows the absorption and scattering by different greenhouse gases in the atmosphere. So the sunlight is a kind of radiation, and for radiation is a kind of wave. So it shows a spectrum of the radiation. Okay, so visible sunlight will be around here. Okay, and then we have these longer wavelength, so the infrared and the others. So these are so different kind of greenhouse gas will have different radiative forcing for different wavelengths. Okay, so in order to make meaningful comparison between greenhouse gases, carbon dioxide is used as a benchmark. As a benchmark is like a indicator for measuring the heat trapping ability of all greenhouse gases, and a time span of 100 years is typically used. Okay, so if the greenhouse gases stay in the atmosphere for 100 years, what is their heat trapping ability equivalent? Okay, equivalent to how much carbon dioxide? Okay, so this is the carbon dioxide equivalent. So it is a measure of greenhouse gas emission using carbon dioxide as the reference global warming potential, because individual greenhouse gas has different degree of global warming effect per unit mass of its emission. So carbon dioxide emission is a quantity that describes the amount of carbon dioxide that would have the same global warming potential when measured over a specified time scale, generally 100 years. Okay, so if a greenhouse gas like methane, okay, if a certain amount of methane, it will produce a greenhouse gas effect. So what would be the same greenhouse effect produced, okay, if the gas is carbon dioxide? So that amount of carbon dioxide, which result in the same greenhouse effect, the same global warming potential to this kind of gas, this amount of carbon dioxide is the carbon dioxide equivalent. Okay, and we are using the year's time, 100 years. Okay, 100 years time. If this greenhouse gas stay in the atmosphere for 100 years, in order to have the same global warming potential, it is equivalent to this amount of carbon dioxide. So this amount of carbon dioxide is called the carbon dioxide equivalent. Okay, so global warming potential is a factor used to represent the ratio of the heat trapping ability of each greenhouse gas relative to that of the carbon dioxide. So let's take an example. Releasing 1 ton of methane into the atmosphere is equivalent to releasing 21 tons of carbon dioxide. So which gas have a high heat trapping ability? So let me do a polling. Okay, which gas have higher heat trapping ability? CH4, methane, or CO₂? So I want you to think about that. So here it said that releasing 1 ton of methane into the atmosphere is equivalent to releasing 21 tons of carbon dioxide. So which gas has higher heat trapping ability? Methane or carbon dioxide? Okay, 3 of you, 4 of you, correct. Methane. Methane has a higher heat trapping ability because releasing just 1 ton is having the same global warming effect to 21 tons of carbon dioxide. So now you can understand why the Environmental Protection Organization will persuade you not to eat beef, because eating beef is from the cow, and the cow contribute a high concentration of the methane, and releasing methane will have higher greenhouse effect than releasing the same amount of carbon dioxide. Okay, so this 21 is the global warming potential. Okay, global warming potential of methane is 21. So it means releasing 1 ton of the methane is equivalent to releasing 21 tons of carbon dioxide. Okay. So to do the calculations, okay, 1 ton of methane multiplied by the global warming potential. So 1 multiplied by 21 will equal to 21 tons of carbon dioxide equivalent. Okay, so to calculate the carbon dioxide equivalent, we just need to multiply the amount of the gas and then their global warming potential. So for example, the nitrous oxide. Okay, so for example, I am releasing 30. Okay, I am releasing 30 kg of nitrous oxide to the atmosphere, and I want to convert I want to convert it into the carbon dioxide equivalent. So I will use 30 and then multiply by its global warming potential. So 310. So the unit will be kg of carbon dioxide equivalent. Okay, so of course you can turn kg into ton. Okay, next slide. Okay, so carbon dioxide equivalent is equal to the quantity of gas. Maybe you can use kg, maybe you can use ton. Okay, and then multiply by the global warming potential. So this equivalent, this carbon dioxide equivalent, is used to compare the global warming potential of different greenhouse gas. So for example, 1,000 tons of methane is equal to 21,000 tons of carbon dioxide equivalent, and 100 tons of nitrous oxide will equal to 31 tons of carbon dioxide equivalent. So you can see the nitrous oxide even have a higher greenhouse effect or global warming potential than the methane and then the carbon dioxide. Okay. This table gives you the global warming potential factors for different kind of greenhouse gases, and 100 years is used for the lifetime in the atmosphere. So carbon dioxide, the global warming potential is 1, and then we have methane, we have the nitrous oxide, and many others. So you can see that carbon dioxide actually has the lowest global warming potential, but we have too much carbon dioxide in the atmosphere. Whenever we burn something, we burn the fossil fuel, it produces the carbon dioxide. Okay, so you cannot say that because the global warming potential of carbon dioxide is very low, then it doesn't contribute much to the atmosphere. No, because the amount of carbon dioxide in the atmosphere is just too large. Okay, so although the global warming potential for or per unit mass is small, but the overall contribution by the carbon dioxide is still the majority of the global warming. Okay, so for the greenhouse gas emission, we have the direct effect, okay, like burning, okay, barbecue, using the town gas, driving, or when you replace your air conditioner and there could be refrigerant leakage, and cutting down the trees. So all these will directly emit carbon dioxide or other kind of greenhouse gases. And apart from direct emission, we also have indirect emissions. So indirect emissions due to energy consumption, like consuming electricity. Okay, when you turn on the lighting, turn on the water tap, use the electrical appliance, go to gym, cook, use your computer, use your phone. So all these rely on the electricity. And we generate electricity by burning the fossil fuels. So in Hong Kong, we have 2 utility companies. We have the CLP, Zhongdian, Gongdang, HEC. Okay, so both utility companies rely on almost totally on the fossil fuels. And for the CLP, they import the electricity from the Daya Bay, which is by the nuclear power. And nuclear power is a cleaner power, more efficient, but still it is non-renewable. Okay, so we are burning many coal, petroleum, and natural gas for producing electricity and others, and all these will indirectly emit carbon dioxide. Okay, greenhouse gas emission factor. You can check the website by CLP, and they will give you their greenhouse gas emission factors. And for the year 2017, the factor is 0.5 kg carbon dioxide equivalent per unit. Per unit. What is the unit? The unit is kilowatt hour. Okay. So when you consume the energy, the amount of energy will be measured by the electricity meter. So you have to pay the electricity bill according to the amount of energy that you consumed. Okay, so the unit rate is around, I think around $0.9 or around $1 per unit. So for my electricity bill, I think every 2 months, I need to pay for around $1,000. So $1,000 means that in this period of time, I have consumed around 1,000 kilowatt hour. And for every 1 kilowatt hour, for every 1 kilowatt hour of energy I consume, I would produce 0.5 kg of carbon dioxide equivalent. So this is the meaning. From your electricity bill, you can estimate the carbon dioxide equivalent because of your energy consumption. Electricity output by generation fuel type. So in Hong Kong, 38% is by burning coal, and then by burning the natural gas 26%, and by nuclear power 35%. So this is the fuel type for Hong Kong. And on the right hand side, this is the total emission in kiloton in different year. Carbon dioxide emission. So we have lower and lower. So some years ago, I think it is because of the increased percentage of nuclear power. So when you rely more on the nuclear power, then the carbon dioxide emission will get less and less. So it is very controversial whether nuclear power is good or not. So in terms of carbon dioxide emission, it is a good energy source because it is very efficient and it won't produce very much of carbon dioxide. But of course, there is a risk for nuclear leakage. For HEC, the greenhouse gas emission factor is 0.76. So compared to the CLP, the factor is larger. And it is because for the HEC, they didn't rely on the nuclear power. So just by burning the coal and the natural gas, and a very small amount of renewable energy. They have the windmill, the wind power and the solar power, but this is only a very small percentage. And town gas, 0.599 kg carbon dioxide equivalent per unit. So according to your own utility bill, you can calculate the amount of carbon footprint and also the fresh water supply. From the WSD, the Water Services Department, you can find these values. So in the year 2008, the emission factor is this. And for other human activities, we also contribute to the indirect emissions of carbon dioxide. Like taking the public transport, you eat the food, consume the food, and you buy clothes, you buy your mobile phone, you buy a present for your friends, and you throw away your clothes, you throw away your phone, and the sewage discharge. And construction, renovations. So all these, actually all kind of human activities will directly or indirectly contribute to the carbon dioxide emissions. This figure is extracted from the Carbon Footprint Management Toolkit for Sustainable Low Carbon Living. So it summarize the carbon dioxide emission for different kind of public transport. Taking MTR, bus, minibus, tram, taxi, or ferry will have different effect to the global warming. So it seems the lowest value will be the MTR. Okay, this is per Hong Kong dollar that you spend, and this is for per km. Okay, so some figures for you to have a reference. Okay, and this is the greenhouse gas emission for food and beverages. So eating beef will result in the highest carbon dioxide emission. Okay, followed by chicken and then the pork, and also fish. Fish also has a high value. Okay, but vegetables will be lower. So if you want to save the environment, then eat more vegetables and less meat. And distilled water actually has a high value compared to tea or coffee. Electrical appliances, electronic products. So these are the carbon dioxide emissions per unit. So this per unit should be per unit of energy consumption. Okay. So washing machine, you're consuming electricity and also water. So we have a higher values. And a notebook computer also has a high value. Desktop computer also high value. And the greenhouse gas emission due to electricity used for sewage. So when you flush away in the toilet, actually it consumes electricity because you need the pump, you need the sewage system to filter the waste before it is disposed into the sea. So all these consume electricity. Clothing. So when you buy the new clothes, it also contributes to the global warming. Greenhouse gas emission of raw materials. Okay, so some figures for you to take a reference. Okay. So you can see that for these human activities, so when you travel, when you eat, when you buy anything, when you use water, when you use the electricity, so all these can be converted into different kind of gas emission. Carbon dioxide emission, methane emission, nitrous oxide emissions. So different activities. Okay, so transportation, electricity, and then other industrial activities, land use, agriculture, and the waste. So in Hong Kong, we all contribute to these activities, and they will contribute to the carbon dioxide, the methane, nitrous oxide, or other kind of greenhouse gas emission. So by this kind of analysis, then we can calculate the carbon footprint for Hong Kong people. So being a service economy without any major energy-intensive industries, the electricity generation is the major source of greenhouse gas emission in Hong Kong. The total greenhouse gas emission in the year 2014 is 44,900 kilotons carbon dioxide equivalent. Okay, so this chart the greenhouse gas emission in Hong Kong from the year 1990 to the year 2014. Okay, so this is the total carbon dioxide emission. So in Hong Kong, the population is getting higher and higher. So maybe it is more fair to look into the per capita numbers. So this figures shows the annual greenhouse gas emission per person, okay, per capita. So per capita calculation is done by dividing the total carbon emissions with the population, which works out to be around 6.2. Okay, so in Hong Kong in the year 2014, our carbon emission is around 6.2 tons per person per year. So 6.2 ton is how many? 6,200 kg. Okay, 6,200 kg per year per person. So it's already very much. The Hong Kong government targets to reduce the carbon intensity to 60% to 70% by the year 2030, using 2005 as the base. So this target is referring to the publication Hong Kong's Climate Action Plan 2030 plus. So because China has joined the Paris Agreement, and therefore the Paris Agreement also applies to Hong Kong. So we need to set the targets. So the target is to reduce 65% to 70% of the carbon footprint. Okay, so it means we will reduce our carbon footprint from around 6 to 3.3 to 3.8 tons per capita. So do you think it is achievable? I don't know. I don't know whether we can achieve it. So we have 10 more years. So it's now already 2020, the year 2020. So 10 years later, can we reduce our carbon footprint to 3.3 to 3.8? I doubt. I'm not sure. Okay, personal carbon footprint assessment. So today or tonight, when you go back home, you can ask your parents for the energy bill. If you live in the New Territories or in the Kowloon, your electricity bill will be something like this. And in the electricity bill, you should be able to find the number of units that you consume in that period of time. So usually 2 months. So what is the indirect greenhouse gas emission from electricity purchased from the China Light and Power between, so in this period of time? The energy consumption is 769 units. And for CLP, if we refer to their website, not this one, this is the HUC. Okay, referring to the year 2017, the greenhouse gas emission factor is 0.5. So we apply this factor to the electricity bill. So 769 multiplied by 0.5 will equal to 384.5 kg CO2 equivalent. So this will be the amount of greenhouse gas emission in these 2 months. Okay, and for the Hong Kong Electric, the consumption unit, okay, 835, and the greenhouse gas emission factor was 0.76 in the year 2017. So it's equivalent to 634.6 kg CO2 equivalent. And from the town gas, you can also estimate your carbon footprint. So in these 2 months, you have 7 and 5 units. So multiply by the greenhouse gas emission factor. So we have 7.18 kg of CO2 equivalent. And for the water consumption, so how much cubic meter? 59. Okay, so 59 water consumption, and multiply by the greenhouse gas emission factor in the year 2008, and we have the carbon dioxide equivalent. 10.148 kg carbon dioxide equivalent. Okay, so this is just a demonstration to how you can estimate your carbon footprint. Okay, from your energy bill, the electricity bill, the town gas bill, the water consumption, and then you may also estimate from how many clothes that you buy, or maybe from what kind of public transport that you take, so you can do your personal carbon footprint assessment. And you may also try to use this calculator. This is the low carbon living calculator, which is developed by the government. So it helps you assess your carbon emission in respect of the clothing, the food, the living, and the travel in the past year. So if you have time, I will recommend you to take a look. So by this kind of calculation, you can have more idea about your impact. So your decision to whether to buy this clothes or not will impact on the environment. So how much will be the impact? You can use the calculator. Okay, whether you switch on the lighting, whether you switch on the air conditioner, so all these will have the impact on the environment. So before you make your decision, think about the impact. Okay, so I will stop the recording now.